Hey everyone, welcome to the second community call. We'll be giving a couple of minutes to make sure everyone has the time to join, and we'll get started right away. Okay, we're 3 minutes past. Shall we get started? Okay, welcome everyone. We'll start by doing a quick round of introductions. Dylan, do you want to go first?
Yeah, so my name's Dylan, and I'm a developer on the Defender team. And today I'll be giving a demo on the Forta integration with Sentinels.
Yeah, hi guys. I'm Nami. I'm part of the Defender product team as well. Work as a full stack developer, and I mainly focus on like the UI and backend features related to Defender admin. And today I'll be talking about the Sentinel API.
Hey everyone, my name is Santiago. Usually go by Pala. I'm the developer here at the Defender team. I'll be giving you a very brief intro of Defender before turning it over to Nami and Dylan to go deeper on Sentinels today.
Hey everyone, I'm Eric. I'm a developer working on our open source developer tools, and I'll be giving an update on our upgrades plugins.
Hi folks, I'm Fran. I help maintain our open source libraries, and today I'm going to be talking about the upcoming changes in Open Zeppelin contracts.
And hello everyone, my name is Adrien. I'm working on the smart contract library together with Fran. And today I'll just be introducing the very first part of our second community call. So yeah, maybe let's go full like this. So for this second community call, basically, first quick introduction of Open Zeppelin. Our mission, again, is to protect the open economy. You'll see that today through all our products. You'll see that through contracts. You'll see that through Defender. We are trusted by a lot of actors of this ecosystem for our products, but also our security audits. And Open Zeppelin is based around like these three aspects, even though it's not growing. Maybe this slide is already outdated with Forta, but we have this part where we are providing smart contracts for building your applications. We are a large provider of audits to improve the security of your application once they are designed. And through Defender and Forta, we also help you manage your smart contract. So with all these features, all these products, all these proposals, we basically can help you at all the stages of the development of your application so that it's secure and it's scalable. Why do we do this community call? This is the second one. Stay until the end because there is a POAP to claim. Maybe some of you are collecting that. Maybe I've stated that before. But why we are doing that is so that we get more feedback from the community, so that we get more involvement. We want to show you what we're working on. We want to provide visibility for the future, but we also want to get feedback. We want to get feature requests. You'll see that some of the things that we're releasing now today has been the result of requests by the community. And we want to engage discussion with the community. Also, we want some of you to review our code, because that's also part of how we achieve security. First thing that we are going to present is a contract, but I think it's also true of what's coming later, but mostly of the contract. We just released version 4.5 release candidate 0, so RC is release candidate. This was just a few days ago. There is a release candidate period for this contract before they are fully released. There is this release candidate period. We strongly encourage you to try them out, but also look for potential issues. And this is where we need you, because security is, I don't know if you know the Swiss cheese model, but it's like layers and layers, and each layer has some holes. But if you have enough layers, at some point there is no hole in the entire system. So a lot of the security comes from our own internal reviews, and the test coverage we do. We're also working with external audit firms for review and formal verification. But there is also the community part that is one of these layers that ensures the security. That's why we have release candidate with an open review period, and that's why we have a bounty system on Immunify. And if you find an issue during a release candidate phase, I think there is a bonus on potential bounties, in addition to a very exclusive POAP for the bug hunters. So everything we are going to present, at least for the contract part, is under review by the community. So have a look and try it out.
Thank you. So we'll move on now to talk about this release that Adrian just mentioned. This is, like we said, 4.5. And this time, like last time, we have a pretty big changelog that I encourage you all to go and see in the repository, because we're not going to cover everything today. And very important note here, notice that there is a small breaking changes section at the end. We take stability really seriously in this project, and so we don't very often do breaking changes, and we evaluate them very carefully. And this one's passed the test for us, but what's also really important is that we include in there those details, and in cases that it's necessary, explanations on what changes you need to do if you upgrade from the previous version to this one, and some of these things break for you. So the first one that we are gonna cover is related to UPS. So this is a new upgradability mechanism that we introduced a couple of versions ago, and we had these fairly complex rollback tests that we had implemented as a security mechanism, because one of the risks in this way of doing upgrades is that an upgrade can accidentally turn off the upgrades, right? And a proxy that was upgradable suddenly becomes not upgradable anymore. And the fact that that can happen accidentally can be concerning in many situations. So we wanted to have a mitigation for that. And what we came up with was this rollback test, which essentially was proving on-chain that when you do an upgrade, you are definitely able to roll back to the previous version. And this gave quite strong assurances that you were able to do that. Now we started to feel that maybe this was too complex, and it doesn't, it's still it's still possible to break it if there is a malicious actor that wants to do that, and maybe the complexity here is kind of obscuring the fact that it's still possible to break it. So we discussed it quite thoroughly. We reevaluated and decided to just simplify this down. And so what I'm showing here in the right part of the screen is the diff, which shows that a bunch of lines were removed, less lines were added. So we see this as a really positive thing. Removing the complexity that the previous mechanism was adding and having something simpler in its place that's still protects against accidents, which was the goal all along, right? This is pending a proposal to extend ERC 1822 that we want to make because we were not able to follow that to the letter because of the way that our proxies work. But so the core of the mechanism is here in these 5 lines, and it's actually really easy, I think, to read it and understand what is expected of a new implementation. But anyway, all of this is documented. So please feel free to go ahead and review it and check out documentation and so on. One of the other changes that is included in this release is some extension to our governance offering, namely the ability to set up governance protocols where votes are based on NFTs, where if an account is a holder of NFTs, they can vote, and they can vote proportionally to how many of those NFTs they hold. This, we've seen it, we saw it in the space before including this here. So we kind of know that people are using this sort of mechanism, and we hope that this will make it easier. The way that we built this is kind of interesting, not necessarily an original idea. Actually, someone in the community suggested this in the issues, and it is that the voting interface was defined like on its own, right? And the implementation for the voting interface, which is the interface here at the left, is modularized. And that means that you can reuse it. What we did here was ship it built into ERC 721. And we haven't done it for other token standards like 1155, but the existence of these votes module, it means that it's actually really easy to integrate it into other token standards or any other sort of contract that could potentially represent votes. And that's, I think, also very thoroughly, I know it's very thoroughly documented. I think it's a good documentation, but that's also something that we invite you to review and welcome feedback on. But the code here on the right, I think, is really interesting because it shows how simple it was actually to integrate the modular vote tracking contract into ERC 721. It's just these like 10 lines minus comments. So, by the way, we're going to be taking questions at the end. So if you have any questions, write them down and we'll discuss it later. Yep. So another thing that's included in this release is Nft royalties, a very hot topic lately. And there is this ERC 2981 that was finalized recently. There was a lot of community discussion around that ERC, and there is a lot of community support. So we felt really comfortable jumping ahead and adopting this one. It's important to note, and this is mentioned in the docs, that this doesn't force people to pay royalties, but it's a way to signal to marketplaces that how many or how much royalties should be paid and to whom. And our implementation of this just makes it really easy to add it to an NFT, writing the address and the percentage of royalties that you want. This is also going to be integrated in the wizard, so it's going to be very easy to set up. Next, this is a very small change, but it's actually, it can have a big impact. And someone here, Claude Shannon, hopefully not the Claude Shannon, because that would be spooky, suggested that we do this. And it essentially is an implementation of the infinite approval pattern, which, there's differing opinions about the validity of that pattern, but the truth is that many DeFi applications use that. And when you do that, it actually allows to optimize the ERC20 token contract in this specific way, which saves on a storage read and write, and that makes the cost of a transfer from cheaper. So this was suggested by a community member, and we discussed it and agreed to merge it. And that's we hope this has an impact on transaction fees for users. Next, this is a very simple library for signed math utilities. We already have math utilities in the math library. If you don't know them, check them out. They're very similar to these ones, but for unsigned numbers, uint. And yeah, this is just a really simple library, except maybe for the average function that we discussed a lot in how to implement in a efficient and safe way. The problem with average, if you don't know, is that if you just do a plus b, all of that divided by 2, that is a operation that can overflow in the intermediate value, a plus b, right? So it's important to be careful when you do an average of 2 or more numbers to keep that in mind. And the math and the signed math library here protects you from that. Again, this was proposed by and discussed with 2 community members mentioned here. And lastly, the one that we're going to mention is also kind of related to NFTs, just a utility for base64 encoding. This is very useful for fully on-chain NFTs, where the token metadata is an on-chain generated SVG. I actually didn't know this, but when you do that, you need to encode it in base64 because it's fully URL safe characters. If you just build the SVG, you can make a data URI, but in order for that to be correct, it actually needs to be base64 encoded, and this is a library that helps you with that. So these are all the features that we're going to cover today. Please go ahead and look at the changelog and try out and let us know what you think of the other features. But also, oh yes, how you can contribute. So Adrian mentioned this before. I mentioned it again. We have a bug bounty on Immunify. The link isn't here, but you can find it on Google if you search. There are rewards up to $25,000 and a special POAP for each release, which is the one that we see here on the right. If you submit a valid issue for the release during the release candidate, that is during the open review period, this is the POAP that you're going to get. And it's like a special edition for the release only. Very important. We've already received actually a couple of reports, and it's been, they've all been fixed, of course. And we are very happy with community members who participate in that. This here is a short link to the release branch on GitHub. And lastly, future looking, we want to know what features you want, what contracts you want, what utilities you want, or what problems you're seeing in your smart contract development work that you would like us to help you with. So we put together this thread in the forum where you can write in and just, I don't know, discuss or share your ideas. Hopefully other community members can go in there and also browse through the ideas and vote using the like button. And we're going to keep an eye on that to make sure that we hear your requests and consider implementing them. So this is all for my part. And now we're going to move on to the upgrades plugins, which Eric is going to tell us about.
Thanks, Fran. All right, so I'm going to give an update on what's available in the latest versions of our upgrades plugins for Hardhat and Truffle. But first, let me give a quick overview of what it means to have upgradable smart contracts in general. So by default, smart contracts are immutable. And this may be useful to ensure that your contracts that you can use your contracts between participants and they cannot be changed. But in some scenarios, you may want contracts that can be changed. For example, you may want to provide bug fixes or security fixes. Or if you're iteratively developing your code, you may want to provide code improvements over time, or add new features in new versions of your contracts. The Open Zeppelin contracts library provides 3 different proxy patterns that you can use in order to write and deploy upgradable contracts. And these are the UUPS, transparent, and Beacon proxy patterns. So for UUPS and transparent proxies, these proxies patterns follow this concept where you have a proxy, which is your contract instance, that has an address, a state, and a balance. However, they don't contain the implementation logic for your contract. Instead, any function calls to your proxy are delegated to the implementation, which is stored at another address. So the proxy simply contains a pointer to that implementation. And effectively, your implementation logic is run in the context of your proxy, which is your contract instance. Now, in order to upgrade a proxy, what you can do is simply change the pointer of your proxy to point to a different implementation contract. And what this does effectively is that this allows you to upgrade the logic used by your contract without affecting the address, state, or the balance. Now, if you have multiple proxies, and if you're using the UUPS or transparent proxy patterns, you may have a number of proxies that are all using a first version of your contract. And if you want to upgrade your implementation logic to a new version, what you would need to do in this case is that you would need to submit a separate transaction in order to upgrade each proxy independently. So if you have n proxies, that means you would need to submit n transactions in order to upgrade each of them. Now, what if you wanted to upgrade all of them atomically in a single operation? Well, that's where Beacon proxies come in. With Beacon proxies, much like regular proxies, any function calls are delegated to their implementation. However, instead of the proxy storing the address of its implementation contract, the Beacon proxy stores the address of a beacon, which in turn stores the address of the implementation contract. So the Beacon proxy simply delegate their calls to the implementation that is referenced by the beacon. And the benefit of this is that this allows you to upgrade any number of Beacon proxies in a single operation simply by upgrading the beacon that they point to. Now, in order to deploy and manage upgradable contracts, Open Zeppelin provides the upgrades plugins that are available for Hardhat and Truffle. And these allow you to use functions in your Hardhat scripts or Truffle migrations, or even in your tests, in order to deploy and manage your upgradable contracts. And perhaps most importantly, these plugins validate that your contracts are upgrade safe. And by validating that they're upgrade safe, the plugins, before they deploy any implementation contracts, or whether the first version or later versions for upgrading, they ensure that your contracts follow all of the rules and practices that are needed for upgradable contract implementations. So these plugins provide a number of different functions that you can use. For UUPS and transparent proxies, which have already been available in the plugins, you can use the deploy proxy and upgrade proxy functions. In the latest version of the plugins that we recently released, we've also added support for Beacon proxies. And Beacon proxies are used through a different set of functions, which are deploy Beacon proxy, and upgrade Beacon. And I'll briefly talk about what these functions do. When you call deploy Beacon with a contract instance, this will validate that your contract instance is upgrade safe. And if the contract instance hasn't been previously deployed, then it will deploy that. And then it will deploy a beacon that points to that instance, that implementation. Then after your beacon has been deployed, you can call deploy beacon proxy any number of times in order to deploy your beacon proxy that point to your beacon. And optionally, you can provide optional arguments for your beacon proxy in order to initialize them. Right. And then once you've done that, then of course you can call upgrade beacon in order to upgrade your beacon in order to use a new version of your implementation contract. Right, so that's an overview of what's available in the upgrades plugins and an overview of Beacon support. If you want to learn more, you can check out the documentation and find some examples there. Now we'll pass it over to Santiago to talk about Defender.
Thank you very much, Eric. So given that this is the first time we're introducing Defender on the community call, we'll start with a brief overview of the platform. So as we have been discussing so far, we have open Zeppelin contracts as well as the tooling around contracts that's meant to assist in development of smart contract systems. And Defender, on the other hand, is a platform for secure operations of Web3 systems. Basically, Defender is a platform oriented to DevSecOps. This is secure operations that cover administration, automation, and monitoring of smart contract-based systems. It's free to use. And it runs on multiple networks, both Ethereum mainnet and all its testnets, as well as Polygon, Phantom, Fuse, Cello, Arbitrum, Gnosis, Binance, and Avalanche. And we're working towards adding support for Moonbeam and Harmony as well. So today we're going to go deep into a couple of features around Defender Sentinels. But before we do that, let me give you a brief overview of the platform. So Defender is split into several different components that play together towards letting you manage and automate your smart contracts. First of them is Defender Admin, which is an interface for running administrative operations on your contracts. The idea is that admin allows you to, for instance, tweak settings, manage permissions, upgrade your contracts, issue an emergency shutdown, manage roles, basically any kind of administrative operations that your system requires, and it makes it easy to execute them via multi-sigs, time logs, or governance contracts, or any combination of them. And the idea is that through this interface, anyone, not necessarily someone with technical knowledge, can create, and more importantly, can review and approve these actions. Admin also integrates with an address book to make it easy to work with your contract, so you don't have to be copy-pasting addresses around. Again, it also doesn't require any sort of privileges or rights over your contracts. It just acts as an interface, and you are in possession of the keys that will ultimately allow you to manage your contracts and send these privileged operations. Another component we have is Defender Relayers. Relayers are basically a platform for simplifying the process of sending transactions, also securing private keys. So each Defender Relayer is powered by a private key stored on a key vault that only your team, only this relayer will have access to. So you know that all operations you send from a Defender Relayer are going to be sent from the same account. And Relayers also provide a simplified API for sending transactions, which manage for you transaction nonces, gas prices, resubmissions, broadcasting from multiple providers. The idea is that whenever you need to set up an automated task that will be sending transactions to the network, you can use Relayer both for securing the private keys, also simplifying the process of sending the transactions and make sure that they are mined and get to the chain. Next, we have Sentinels, which is going to be our main topic for today, but just for a brief intro, Sentinels allow you to monitor both transactions and Forta agents by defining conditions on what kind of things you want to look out on chain, and allow you to define what actions you want to execute if you spot any of these transactions. Could be sending an email, a Discord message, Telegram, Slack, push the information to Datadog, or trigger an Autotask. So Autotasks are functions that you can define on Defender that they will be executed by Defender, so you don't need to run your infrastructure for executing code. And the idea is they act kind of as a glue between the different components. You can trigger an Autotask from a Sentinel in response to an event you see on chain. You can schedule to run them regularly via a cron expression, or just generate a webhook so you can invoke the code from any other system and use the Autotask to integrate Defender to your regular workflow. Last, we have Advisor, which is a knowledge base where we have been compiling best practices around development, testing, monitoring, and operations of smart contracts after years and years of both audit work and work on open Zeppelin contracts and basically secure smart contract development. The idea is that you can use this knowledge base to find out which kind of controls you should be implementing for your system, depending what stuff you're working on. So I strongly encourage you to check out Defender. Remember, it's free to use. You can also check out the documentation for all the for more info on all the different features that we support. And also jump onto the forum, where we're also gathering feature requests for Q1. So if there's anything you would like to see implemented on Defender, please let us know. We'll be happy to add it to our roadmap. So with that, Nami, floor is yours.
Thanks, Paulo. So hi, everyone. I'll be introducing the new Sentinel API. We've included this as a package to the Defender client, which is now a public repository, by the way. So before I jump in, I'll give a quick recap on Sentinels. So we have two types of Sentinels, as Paula mentioned, one for contracts and one for Forta. So the contract Sentinels allow you to monitor transactions of a contract. So you can set notification alerts that are triggered based on certain conditions, such as events, functions being called on the contract, or transaction parameters, even S value. And then Forta Sentinels allow for monitoring of Forta alerts, which Dylan will explain in more depth next. So these notifications can be sent over a number of channels, such as Slack, email, Telegram, Discord. We have a few more, I believe. But more importantly, we can also execute an Autotask automatically once a notification is triggered. So there are some differences in use case as to when you would use the UI and when you would opt in for the API. So for example, the API could be used when deploying an ERC20 contract. You could programmatically create a Sentinel that monitors high-value transactions as part of the same deployment script. You could even delete older or unused Sentinels whenever you create a new one, all in the same script as well. You could use the API to create multiple Sentinels at once, or even for several contracts at once. So the UI does not support bulk creation or management of Sentinels. So this feature makes the API in particular very interesting. You could also manage Sentinels, for example, to pause or unpause based on some internal process or custom condition that you define in your code. So we have a bunch of examples on how to use Defender client on GitHub. So there's a link in this slide as well, so you can have a look. Let me just share my screen to jump into one of the example scripts. All right. So here you can see an example script that creates a Sentinel programmatically. So first we import the Sentinel client and then set up the credentials. Reading these from an environment file, you should create your credentials through the Defender platform under the account settings team API keys. And make sure to toggle manage Sentinels as well, so that this feature works. Then we set up the client with the credentials. In this case, what I'm doing is I'm listing all my notification channels. And if I do have any, then I just assign it. If I don't have any, then I will create a new email notification channel to john@example.com. And then what we do is we populate the request parameters. So most of these are optional, as you can see. And these are typed in the package as well. So you could find the interface in models under the name external create subscriber request. So we start with which network we want to use, the confirmation level, which you can set if you only want to be notified after a certain level of confidence. So you can choose a higher confirmation block level if you wish. Then we set the name of the Sentinel, the address of the contract that you want to monitor, and we import the API, which I've just imported from a JSON file. And then there's three conditions. So we've got event conditions, actually 4 conditions if you include Autotask. So we've got event conditions. In this case, I'm monitoring for 2 events. We've got 1 function condition and the transaction condition. This transaction condition applies globally. And then we have an Autotask condition as well, which essentially allows you to add an additional filtering if the other conditions are met. So this Autotask can contain some custom logic to decide whether or not you want to actually trigger the notification. And then we can also set an Autotask trigger, which is triggered if all the conditions are met, as Paula mentioned before as well. And then we have the alerting threshold. In this case, I have 2 alerts every hour with no timeout, and then we assign the notification channel from above. And then finally, we simply create the Sentinel with the request parameters. I'm not sure if it's going to automatically go back to the slides. Perfect. So yeah, we have, there's a couple of resources available. So if you want to have a look, we have the example script that I just showed. There's a bunch of other examples on how to use Defender Client in general. We have the actual Sentinel package on GitHub as well, and some documentation on how to use the API. Yeah, that's pretty much it on my side. I will pass the mic to Dylan.
Thanks, Nami. So I'm going to give a demo on Forta Sentinels. So Forta Sentinels are one of the latest additions to Defender. As Paula and Nami already explained, contract Sentinels allow you to monitor transactions going to a smart contract, and Forta Sentinels, they allow you to monitor Forta alerts. For anyone who doesn't know, the Forta network is a security network for smart contracts, and it allows users to get real-time alerts on smart contract-related threats. So the network consists of developers who write Forta agents and nodes who run those agents against on-chain transactions. So a Forta agent is basically just a script which detects specific events and conditions within a transaction. So for instance, you might have an agent which detects high gas fee or reentrancy, or even change of ownership on a contract. So I'm going to show you how to create a Forta Sentinel, and I'll give you a few examples on how you might use them. So give it a name, choose the network, and we've 2 main filters, the address filter and the agent ID filter. So you can just choose to monitor a single address with a Forta Sentinel, and the Sentinel will forward all alerts related to that specific address, regardless of the alert type. Or you could put in the ID of an agent here. Say, for instance, you wanted to manage the flash loan agent. You could put in the agent ID here, and you would receive all alerts related to flash loans, regardless of the smart contract it was related to. But you could also put in multiple contract addresses. So if you had a suite of contracts, and you could monitor all alerts related to them, and you can put in multiple agent IDs, so you can receive a vast array of alerts related to different alert types and all of your contracts. So we have 2 conditions, the severity and the alert IDs. So severity indicates the impact level of the alert, and this ranges from info level to critical. So if you only wanted to receive alerts which were deemed as critical, you could choose critical here, and the Sentinel would only forward you those alerts. And we have alert IDs, which basically are a unique string to identify the class of finding, and these are useful for filtering on more obscure scenarios. Finally, we have the Autotask condition. And what this allows you to do is filter the alerts by some custom logic. So I have an example set up for you. So if you wanted to receive alerts related to high gas fee, I think the default for the high gas fee agent is alerts. You'd be alerted if it was greater than $100. But if you only wanted to receive alerts which had a gas fee of, say, $500, you can create a Autotask condition, which is going to define your custom logic, and I have an example here. So the Sentinel will forward the Autotask an array of the alerts. What I'm doing here is I'm looping over them, and I'm getting the gas price, and I'm checking if it's greater than 500. If it is, I push it to my filtered array, and I return that to the Sentinel. Then the Sentinel is only processing the alerts with gas fee greater than 500, and you'll only be notified about those. So the next step is the notifications, and you'll see we have another auto task here. So after the alerts have passed all your filtering, you can choose to do some custom processing with it. So if you wanted to call some external APIs, or say, for instance, you could call some other contracts. A silly example would be if you had a critical alert come in and it passed all your conditions and your custom conditions, and you decided it is actually genuinely critical, you could have an auto task set up that would pause your contracts. And we have the notification channels, which Nami told you about. We also have a custom webhook, so we can forward them all to an endpoint of your choosing. You can process them there either. I just have a Telegram Sentinel channel set up at the minute, and we also have notification throttling. So if you have a particularly noisy Sentinel, you can choose to limit the amount of notifications it sends you per hour. So I already have a Forta Sentinel set up, so a reentrancy Forta Sentinel. So we haven't filtered on any addresses. We're just monitoring one agent, and it's been sending me alerts to my Telegram channel while you all have been listening to everyone else. So here's an example of a Forta alert. So you get the name, the description, the protocol, the network it happened on. We also get the transaction ID. So this is the Ethereum mainnet transaction ID. And we get a link to the Forta Explorer. So this is the alert on the Forta Explorer. And from here, we can click through to see the actual transaction on Ethereum mainnet. So if you go into to view the Forta Explorer, so it's explorer.forta.network, you can see all the top protocols that it has covered. So you can see all the alerts related to 0x, for instance, or you can choose alert types. So you can click into alert types and see all the smart contracts that have reentrancy detected. So Coinbase, Uniswap V3, and 0x. And when you click into alert, you get more details, such as the addresses that were affected and the agent ID, which you would then paste into your Forta Sentinel. So that is a quick overview of Forta Sentinels. Our docs have a lot more information, so if you want to take a look at them. But in the meantime, if you have any questions, let me know.
So, thank you so much, Dylan. Okay, so we have a couple of links, so you can check our documentation or blog. You can join the forum to ask any questions or share what you're building with the rest of the community, or share any feature requests with us. On Defender, you can basically sign up and also check out the main features of the platform. You can see future and past events on the events URL. And last but not least, we're hiring. So we're hiring for multiple roles. We're hiring security engineers, full stack developers, UX designers, project managers, developer advocates, DAO advocates. So if you're interested in any of these positions, go to Zeppelin/join and shoot us a message. Okay. Yes, here's the link to the poll. Okay, I think we can start going through questions. I think we have 3 so far. We can probably start with, we have a question about Beacon and its differences with UUPS. I'm not sure, Hadrian, Fran, or Eric, which of you want to take it?
I can take it. Yeah. So very quickly, to have an overview of all the proxy we propose, we have proxies like the historical one is a transparent upgradable proxy. This is a proxy that has an implementation that is stored in the proxy. And the proxy also contains the upgradability feature. That's an all-in-one package for upgradability that is very safe because you cannot remove upgradability from it, but it's also a bit more expensive to deploy and to use. We have the UUPS, which is a lighter version of this pattern, where all the access control mechanism and the upgrade mechanism is not in the proxy itself. It's in the implementation. So that's one that is lighter to deploy, but that can possibly be breaking during the implementation. That's why we have this security mechanism that Fran discussed, and the upgrades plugin will also help you not break everything. The beacon is really different from those two contracts that are the transparent, upgradable, and the UPS proxy, in the sense that the beacon proxy reads its implementation address from a beacon. So basically, the beacon proxy will first do a static call, a read call to the beacon, ask it what is the implementation, receive a result, and then do the delegate call to that. This means that if you modify the address that is stored in the beacon, not in the proxy, in the beacon, this will instantly and automatically affect all the proxies that are using this, all the beacon proxies that are using this beacon. So yeah.
I think still the question is aiming that, I mean, if all the upgrades can on multiple UPS proxies can be done atomically via Flashbot bundle, and gas is not a big concern, what are the advantages of going with Beacon?
I mean, you could use Flashbot bundles, but when you have multiple UPS implementation and you want to upgrade them, they win one storage slot update per instance. So even in the remote case where you were not paying for your gas at all, if you have thousands, tens of thousands of UPS implementation, you still have thousands of tens of thousands of slots to upgrade. That would potentially not. There is a limit to how much updates you can do in a single block.
We lost him, yeah, so Adrian was mentioning the cost, but I was also going to say that Flashbots doesn't really guarantee atomicity of the bundle, because once the bundle is mined, it's very possible that there would be an uncle block, right, or anything like that, and that can result in breaking up the multiple transactions. So it's not really a secure way of doing simultaneous upgrades. If it's not critical, maybe it could be used for that. So the advantage, I would answer to the question, is guaranteeing atomicity fully, if that's what you want. And cheaper cost.
Awesome. As for, let's tackle the other question we have also on Beacon Proxies, whether it be the idea for factory contracts, creating data contracts and keeping track of those. Correct me if I'm wrong, Fran, Adrian, or Rick, but basically the Beacon will not keep track of all deployments, at least not automatically, not unless you add some additional logic. Basically, it is the proxies that point to the Beacon, but the Beacon doesn't have knowledge of all the proxies that point to it.
Yeah, so keeping track of all the other deployments is it would be the responsibility of a factory. Is it the Beacon ideal for factories? I mean, I guess it's kind of independent, like an independent dimension. If you want to do a factory, it could go with a Beacon, but that's really useful if you want all of the other things from the Beacon. Other than that, might as well just be a UPS proxy, right? And you can also keep track of those. So it's kind of independent of whether it's a Beacon or not.
Okay, we have a question also on the difference between Forta Sentinels and contract-based Sentinels on Defender. Dylan, do you want to take this one?
Yeah, sure. So contract Sentinels, they allow you to monitor transactions going to a smart contract. And within the Sentinel, you can then define conditions on the transaction. So if you only wanted to monitor transactions which you're calling a deposit function, for instance, you could set up the Sentinel to only notify about those, but you can also monitor specific parameters to that function. So if you only want to be notified when the deposit was called with a destination of a particular address, you can do that too. Whereas the Forta Sentinels, it's for monitoring alerts on the Forta network. So whereas smart contract Sentinels, you can define conditions on the functions and events. With the Forta alerts, we have a whole separate network where developers create scripts for detecting specific events within transactions. So the Forta agents would be much more flexible, but for quickly setting up an alert on a smart contract, a contract Sentinel would be the easiest way to do it.
Awesome. Okay, let's tackle the one on Autotasks, whether there is an easy way to update Sentinel Autotask logic with a continuous integration via Git push. We have an npm package called Defender Autotask Client, which basically allows you to programmatically update the code of an Autotask key control. So you can hook that to your CI/CD pipeline using GitHub Actions or whatever you prefer, so that whenever you push to a certain branch, you can use the Autotask client to automatically update the code on your Autotask to match whatever you have just pushed to source control. I hope that answers the question. Okay, on Fran, we have one Solidity doctrine.
Yeah, I'm curious who asks this. I wonder if it's the person that also reported, well, we interacted in the issues, but if not, please reach out. There is a rewrite of Solidity docgen coming up. I am taking a little longer with it, one, because I have to find the time, but also what I'm doing right now is polishing the default template so that it includes all of the relevant information, and it's looks nice, and I can release it with a tutorial. But one thing that I could do is, would make sense, is release a beta so that you can still use it and help in the development process until it can be fully released by testing it and providing feedback. So please reach out anywhere in the issues or wherever you can get to me. This is a rewrite of our documentation generator that we use for our documentation, but it's also out there, so you can use it for your projects. Nowadays, there are a couple of alternatives out there, hard hat plugins and stuff that, they're good as well. I would say the thing that sets our tool apart is that it's extremely customizable and doesn't force you to use any site generator. In other words, you can incorporate it into whatever is your favorite fashionable static site generator, of which there are many. And you can also completely customize the output to look in any way you want or include any of the information that you want from the contracts. So it's very versatile, and we have found that very useful, and hopefully you can too. But this rewrite is making the code a lot simpler and easier to contribute and maintain and so on. But it's taking a little while to finish up the template, the default template. Yeah. There was also a question couple questions in the YouTube comments. One of them is if there's an example of Beacon factory, I think. There is actually there is no factory in the contracts library out of the box, mainly because it's actually quite easy to write one, just a few lines of code, although this argument is getting old. But there is a discussion, a thread about that in the forum that hopefully you can easily find by just searching the forum for factory. and going to the one with the most comments. And there are several examples there of factories for the various kinds of proxies. And there's also a question about floating point arithmetic. So this is, well, this has been discussed many times, and obviously we don't have, well, I wouldn't say floating point, but like rational numbers, or like a fixed point, anything that allows working with decimals. That's the word. We don't have anything for that. But there are many alternative libraries, or like, libraries that are focused on arithmetic with decimals. So I would love to know, one who asked this or whoever, if you've looked at those, and if you would like to see an Open Zeppelin decimal arithmetic library, why? And maybe you can write that in the request forum thread that I shared. What you would like to see, especially about an Open Zeppelin implementation of this. And if you look at the others, yeah.
One thing I'd like to add about that is, for a long time, maybe not about floating point, but at least for fixed point, the Solidity team mentioned that it's something that they wanted to work on, and obviously it hasn't shipped yet. And the last echo I got from that was that they were considering adding a type for the fixed point, but not necessarily add all the operators on this type. And the thing is, when we ship code, we take it very seriously to maintain support for it and backwards compatibility. And we were very much afraid that if we were to create dedicated structures, they could become obsolete whenever Solidity provided something. So if our position, I think, was that if Solidity was to provide a definite data type to build libraries on top of that, then we would possibly definitely jump in and try to provide utilities on top of this data type. But we didn't feel really comfortable initiating a structure that our users will depend on, that could potentially become very quickly obsolete.
Okay, and we have the last question, which actually I think it was the first question asked. I'm not sure what Anonymous had in mind around designing smart contracts. I mean, we have the contracts wizard, if it helps, that basically gives you a UI so that you can basically specify the settings or the requirements you want for your ERC20, Sentinel 1155, or Governor, and that will produce the code for you that you can download or import into your project or just send to Remix. But I'm not sure if this question was geared towards something more about creating a visual diagram or that kind of stuff around smart contracts. If that's the case, we don't have any tools around that.
I would add, it's not exactly an open source tool, but the forum can be a resource to help design smart contracts. If you, it can be hard for us to keep up. There's a lot of content there, but if you write a well thought out and well written post asking for advice on smart contract design, it'll probably stand out and you will get some answers.
Seems like we're exactly on time. Well, thanks everyone for joining, for listening. Plan is to have another community call about 1 month from now. And if you have any other questions, any follow-ups, feature requests, or anything you want to share, just head on to the forum, forum.openzeppelin.com, and we can keep the conversation running there. And remember that we're hiring. So if you're interested in joining the team and help us build anything that you've seen today, definitely shoot us a message. Okay, everyone, thank you so much for being here, and see you next time.